All right. I think we're in our precursor hour. Hopefully people are starting to trickle in. We're just going to do a pre-roll kind of conversation while we wait for the stream to catch up. If you are on YouTube now, feel free to jump into the chat. We're monitoring the chat to see what where everyone's at and what everyone's doing tonight. So yeah, I'm going to wave to everyone from my side. This might be awkward until people figure out that we've started. Feel free to jump into the I see the feed going, which is cool. People are shy, I think. But Josh and Mitch, I see you on the internet.
I see myself and you too.
Yeah, just give me a moment. I had to actually send my wife the video link so I could use her computer and get the.
Nice.
Yeah.
Oh, there's Mitch.
Just getting chat working there.
Let's see. We have, let's look at the meetup page. 98 attendees registered. It's pretty good number. We typically get.
Dan is here.
Oh, hey, Dan. You know, when it comes to in-person events, you know, if we get 90 attendees, we typically get like 40 in person. So, you know, something like 30 to 50% is actually really good for in-person meetup. So I'm super curious to see how many folks will join live, just given the quarantine, stay at home, whatever it's called by you, and sort of a fix for learning about WebAssembly or at least chatting about it. Where is everyone dialing in from?
Shout outs from the East Coast.
Country, maybe.
My wife is yelling at me to move over so that I'm more centered. Oh, that's good. I like that.
All right. So far, so good. We haven't been blacklisted by YouTube yet for streaming secrets of WebAssembly.
Oh, whoops. Whoa. Hey.
You're getting a little live inception.
No. My wife had software running and I didn't notice. Here, let's see. Oh no.
It is all good. We got plenty of time before we do the live stream or before the talks start. We're just looking who's representing here. Some of the earlier folks. We have let's see, going from the top, Waterloo. That's you, Mitch. Connecticut, New Britain, Connecticut. Hard hitting. I got Waterloo, another Waterloo.
Oh, who's that? I don't know him. Just kidding. That's Duncan. Duncan's on our team.
Awesome. And then Berkeley, just not too far from where I'm at in San Francisco. Ooh, Los Gatos, a little south. So we typically get, as you can imagine, in the Bay Area. If you're not from the Bay Area or you've never been here before, right? We have San Francisco, which is just the city, sometimes call to it, but we have a whole bunch of major cities in every direction: the North Bay, the East Bay, the South Bay. Silicon Valley is the South. So you think if you Google's in Mountain View, Palo Alto, Stanford, and a whole bunch of cities like Los Gatos. And then we have East Bay, Berkeley, and a bunch of other bigger communities, or UC Berkeley is based. And then we have Northern California, where the more north you go, the lovelier it is, because that's where wine country is. We typically get people from all around the Bay Area, largely what we call the peninsula, where San Francisco and the South Bay are kind of all connected. We've gotten folks coming in specifically from Sacramento, which is not a short drive. We also have people from out of town coming in all the time who happen to be here for work or for a conference. So I'm pretty excited to see what kind of international or non-regional crowd we get. We got our first question, pre-question: are the talks getting recorded? Yes, because we're using YouTube Live, it gets automatically recorded. Afterwards, it'll be available on the same YouTube channel that you're probably watching this on. Hello, friend. All right, where are we at in our rolling? All right, the first few. I'm hoping people are not working too late today. Here in the Bay Area, it's almost 5 p.m. or 1700. So depending on if you're working a full day today, you might be coming in late. We usually do it later. We usually do it closer to 6:30, or basically an hour and a half from now, because we give time for people to commute if they work, in the South Bay and our events in San Francisco, or if we happen to do a South Bay one coming in from the city or the East Bay. But since most of us are in their houses, there's no commute. So we thought it'd be better to start earlier. All right, more people trickling in. We technically haven't officially started yet, so I'm not surprised. But we wanted to just make sure we get all of our technical configuration figured out for all of us, as well as for the live stream, which looks like thumbs up for Mitch and Josh. Our uplinks and downlinks are looking pretty good. The YouTube Live is chugging away. So since we have a few minutes, I'll describe our setup. We're actually using everything free as an experiment. So today will be one giant experiment, both from a live stream perspective as well as from our setup. We're actually using a video conferencing application that's both open source and freely available for the community. It's called Jitsi, and it's probably a watermark somewhere on the screen. It's a cool product. I discovered it earlier this year. It's like any other real-time communication platform. I believe it's using WebRTC as its primary communication technology. It's actually developed by a corporation, a business. It's 8x8, but they maintain the open source version as, I think, part of their core product. So you can go on GitHub, download Jitsi. They have a Docker file there, so you can spin up your own Jitsi instance. We're actually using the free and publicly hosted meet.jit.si. Seems to be stable. If we have hiccups this time, I'll probably try to do a self-hosted version. But it's a chat app. It's helping the three of us communicate asynchronously as well as screen share. But the neat thing about Jitsi, and why we chose it for tonight's event, is because they have a one-click or very easy integration with YouTube. So with very minimal setup, we can connect the Jitsi conversation to YouTube Live, which is connected to our YouTube page. And there is no additional software required. So it's all WebRTC and streaming from Jitsi servers to YouTube. And that's important because most live stream setups require the presenters to have special software like OBS, which is great, but adds more complexity. And my laptop actually can't handle it. So that's another reason to try it. Anyway, that's the setup. We actually blogged about it when I first discovered the setup works. So if you're more interested, I can share you the full-on configuration. Oh, we got folks from dialing in from Western Connecticut, Southern Connecticut, Germany, Seattle, Moscow. Ooh, that's awesome. Josh, you said you're in New York, right? Or
No, I'm in Connecticut.
Connecticut, that's right.
Like,
Yeah.
all my kids say hello. So, hello from my children.
Very nice. Just let's pull up the Medium post. I'll post the Medium post of our setup. It was super easy, and so far it's working out for us. The key requirement was it should be free and or possible to do with open source. Question is, someone asked, does Jitsi use WebAssembly? I'm actually not sure. I have a sneaky suspicion. They have a beta blurry background feature that if it's not WebAssembly, it probably should be. And there's probably other opportunities to make it using WebAssembly. But go check out their repo. Ooh, we have Alice, Aaron, and Leanne say hello. I wonder if that's related to Josh.
Those are my kids. Yep.
Yeah. Cool. Oh, and we have more folks from SF, A, whichever direction you are calling from. Cool. More people are showing up. I'm going to ask in the chat, what is everyone working on right now? Related to WebAssembly. Uh-oh. Does Jitsi stream audio along with the screen sharing without fuss? Well, we've had no fuss so far. We'll see how much fuss we get in the next 2 hours. But yeah, it's just like a traditional video conferencing application with screen share and video and audio. And to Deco's question about does this use WebAssembly, it's worth shouting out another project which is super cool. It's called Pion. It's actually a WebRTC project written fully in Go, but they are able to compile some of their software into WebAssembly through the native Go implementation, Go support of WebAssembly, and it's actually kind of interesting for testing and to see where they go and how to use some of the client code, server code on the client. I'm not quite sure how it all works, but I saw a demo of it and they've done a talk about it. So that one's a cool project. It's called Pion, P-I-O-N. Pion B. A great community around WebRTC. Let's find the WebAssembly demo. No. Oh. For those who are interested, I'll post that. Hangouts easy with screen sharing with audio. Yeah, I've had mixed results. I haven't tried the new Google Meet, which is now free for everyone. I'm supposed to do better with screen sharing. Hello, Kevin Z from from cloudy San Jose. Welcome. So how, anybody working on projects?
I could chime in. I had a small project I worked on recently that isn't what I'm talking about today.
Oh, cool.
There's the old school MUD servers where you used to be able to play D&D via text.
Yeah.
And that runs on the Telnet protocol, which is powered by all sorts of old programming languages. And I used mscript to port live Telnet to WebAssembly. And that was a trip and a half. I could do a whole talk on that.
Well, we'd be happy to invite you for a future talk about it.
Yeah, sounds good to me.
So, out of curiosity, networking, WebAssembly, Did you go into WASI and how'd you work around that?
So live telnet doesn't assume what kind of socket you have. And all you have to do is say, take the bytes that come in from the socket and then pass it into live telnet, and it does the job. There's a whole like protocol layer on top of the socket. It's very cool.
Awesome. And did you post that online?
Yes, I can get the link right here.
Yeah, I can post it. I can post it into the YouTube live stream. Tim from Queensland. Oh, Aaron's here. What's up, Aaron?
Yeah, so fun fact, I wrote all the glue code from scratch instead of using Emscripten's glue code.
Ooh.
And that made it faster. So now you can use telnet in JS. Have fun.
Whoa. That is pretty cool.
Guaranteed it has memory leaks. It's written in C, so it has memory leaks. I just don't know it yet. I can't wait.
That's pretty neat.
Right.
So we are officially at the start. I'm expecting more people to start showing up. Let's give them a little more time. We have plenty of time allocated for this night. I do appreciate you both working in the later evening. So we'll talk more about who you both are and this event. But we'll just give more folks some time to pop in. In the meantime, you know, Aaron Turner's chatting up. Yeah, my dog's doing great. Thanks, Aaron.
Oh.
Cool. This is my first YouTube live stream as an administrator, and it's pretty good, pretty good. I feel like I'm at the helm of a Starship Enterprise. Unfortunately, you can't see what I'm looking at, but for anyone who's planning on doing their own event, you know, definitely check out the blog of using Jitsi, but there's a ton of different ways. I have not done a lot of prep. These two have done all the hard work, and it's just a few clicks of a button. And I encourage more people, especially who run local meetups, to do something like this. Even if it doesn't work out great in terms of technology, it's so far been pretty good. All right. We are at the 5-minute mark. Hello to South Carolina and to Toronto. Well, you know, our friends in the north are representing. In a few minutes, we'll kick things off with our speakers, but I might as well just get started with our normal introductions. So hi, everyone. If you're tuning in live, thank you for staying up late or waking up early or just finishing your day and wanting to learn about WebAssembly. My name is Jonathan. I'm the organizer of WebAssembly.SF. That's the local Bay Area meetup dedicated to WebAssembly. We haven't been running these very often, partially because if you're not in this current situation with us, we're in either shelter in place or lockdown with the global pandemic. And so we've never done a live stream. Well, we did one live stream and it did not turn out well, but it was also an in-person event. So this is our first official live stream. So thanks everyone for joining, as well as our fearless speakers who are our guinea pigs. Josh and Mitch, I'll be introducing them in a few minutes. First and foremost, we have a code of conduct. It applies just as much to this live stream as it does to our in-person event. It's on our meetup page, and it's not too long, but it basically means be excellent to each other, be awesome, be respectful, especially in the YouTube live chat, and we should all have a really good time. Here's when I typically talk about bathrooms and Wi-Fi, and I hope you have both figured out in your own house. And our sponsors, well, we don't have sponsors this month because it's all using free software, but I did want to give a huge shout out to Aaron Turner or as everyone knows, Torch 24. He actually helped organize this event. He connected us with Josh and Mitch and found us speakers. So I'm calling you a co-host. Aaron, thanks for helping us this tonight. And if you don't know Aaron, he actually was one of our earliest speakers, and he gave, so fortunately enough, the first talk on AssemblyScript, which is the theme for tonight. His talk is also on this YouTube channel. You should check it out, and his cool emulator projects. As I kind of cut to the byline, we decided to do a themed event. So both speakers will be speaking about their experiences working with AssemblyScript, as well as the projects they're working on, and actually quite different. So you'll have some different perspectives. The other thing about this, it's both our first real live stream and dedicated to a particular topic. Both speakers are not in the Bay Area, and we really want to try to experiment with reaching out with folks who may not be in our neighborhood, especially since we can do this live. So both presenters are actually on the East Coast of North America. And so we hope to experiment more with that. Definitely we're seeing a bunch of people from around the world tuning in, from Germany to San Francisco and Canada and everything in between. We have Queensland as well. So of course we have recorded videos. We've always recorded our events, but this is it's different. So I'll be moderating the YouTube chat widget thing. So if you have questions for anyone during their talks, and Josh or Mitch, or even afterwards, feel free to pop them in there. And then after each speaker, we'll also have time for real-time Q&A. And again, I'll be reading them and then asking the speakers more about it. So let's see, anything else about the event? I learned about there's a Slack for AssemblyScript. So if you're on that Slack, it seems like a lot of folks are hanging out there. There's also a WebAssembly Discord channel dedicated to AssemblyScript. I think some of the folks are doing dual duty between the two different communication mediums, but it's a great place to learn about WebAssembly, talk about WebAssembly, as well as get help from AssemblyScript. I think that's it for my preamble. I kind of went on for a lot longer than I normally do. But yeah, I'm just excited to get this meetup back up on its rails. And with that, I'm going to turn it over to Josh, our first speaker. Josh is a developer. If you were here earlier, he's doing a bunch of open source projects around AssemblyScript. He's also the only developer at his company. And so that makes him the most senior developer at his company, as well as the senior architect, everything in between. Josh got connected with us thanks to Aaron, and he's going to talk about his journey, learning AssemblyScript, and a little bit about background of AssemblyScript, and some of the projects he's working on. And with that, I'm going to hand it over to you.
Awesome. So first and foremost, I actually have the slides up on slides.com, and I believe I've shared the link in the local chat with John. And if he would be so kind, he could share that link to everybody. And you can actually watch the slides as they move locally on your computer if you happen to be on a computer.
I just posted it to YouTube. Let me verify on my end. Oh, yeah, there you go. Great.
Perfect. Yeah, so you should be able to follow along as I go through the slides. And today's talk, I wanted to talk about aspects of great testing software. Now, that's just a play on words because the name of my testing framework is Aspect. And I wanted to share the first journey I took through WebAssembly. Maybe it's not the first, but it's definitely the first big one that I definitely trudged through. Yeah, so let's get started. Who am I? My name is Josh. I'm Joshua Tenner, and I'm the senior web developer at the Husky Dental program, and I'll share a little bit about that in a few seconds. I'm a husband.
Hey, Josh, before I cut you off, are you screen sharing?
Oh, cool. So I should actually screen share the thing here.
Yeah, might as well.
All right, just let me make sure. Is it working?
Yep, I see it.
Perfect. All right, cool. So this is the most important slide. This is my family. All three of my kids, Alice, Aaron, and Ian, they're right here. The one in the bottom right is the loudest, and he's the most awesome. And my wife's there in the middle. I am also a Girl Scout troop leader, and I think my Girl Scouts are watching tonight, so shout outs to all of them. Let's see. And I work for the Connecticut Dental Health Partnership. Now, the Connecticut Dental Health Partnership is actually the Medicaid program, and we're contracted out to actually perform the dental part of the Medicaid program. And with my work experience, it's been about, 7 years now where I've been doing solo DevOps at this company. And my motto is automate as many things as possible. And it's been an absolute blast. I'm also a full stack web developer, and I do desktop software and back-end work. I'm basically a jack of all trades. It's a lot of fun. And of course, I figured we should start off with an agenda and actually talk about what this talk will be about today. Today, I want to go over WebAssembly, what it is, especially for people who don't know what WebAssembly is. Then I want to go over what AssemblyScript is, how I started with it, and what my testing software is, and how to actually get started, which will be followed up by a live demo where I'll actually bootstrap an entire AssemblyScript project right here in the browser, and you can get started today too. So let's definitely do that. So let's definitely go over what WebAssembly is. WebAssembly is a lot of things, but mostly it's a compile target. And what you want to do is you want to take your code in your language and then compile your code to WebAssembly so that it can run in the browser. Or in a lot of other people's cases, there's places where you can run WebAssembly that isn't the browser. And it's comprised of a whole bunch of very special bytecode instructions that resemble math, bitwise operations, loading and storing data from linear memory, and SIMD. The number types that are supported in this language is 32-bit and 64-bit floats and integers. That's both of them. And as an end result, it allows you to actually get very, very consistent performance for heavy CPU loads in the browser. It's very, very powerful. And that has a lot of meaning to people. In fact, a lot of people decided to get up and actually, create their own compiler. And of course, I'm actually talking about AssemblyScript. AssemblyScript is a TypeScript to WebAssembly compiler. And it's wonderful for heavy CPU loads. It allows you to handcraft very, very fast and predictable performant functions that run inside the browser using a language that you're very familiar with as a web developer, especially if you use TypeScript. Of course, it comes with a couple caveats, like you have to write your own glue code. And what does that mean? It means that you have to actually tell the browser how to communicate with the linear memory inside of the WebAssembly module. And that takes a little bit of time to learn, but I highly recommend learning how to do it. And once you're done actually figuring out how to work with WebAssembly, you can publish a module to NPM and everybody can get all of the benefits of all the software you wrote very, very quickly. All right, so now that we know what WebAssembly is and now that we know what AssemblyScript is, I'd like to talk about where I started. It was about a year and a half ago when I finally decided that I wanted to start actually building stuff in AssemblyScript. And there were a lot of reasons why I decided to do that. One of them was I wanted to build Canvas applications and do very, very fast request animation frame loops to get like predictable performance in 16 millisecond frames to get games in the browser. And what I got instead of very, very fast performance was very, very consistent performance. And it's gotten better over the past year and a half, which is great. Let's see. Of course, there were a bunch of other problems that I had with it because there was no real good way to actually test my modules. So if I wrote AssemblyScript, I didn't have a really good way to bootstrap my modules in a testing framework. And since I loved building tools, I figured why not just make a quick and dirty testing module for AssemblyScript. And better, I could actually replicate some of the more popular testing frameworks. What ended up happening was I decided to take Facebook's Jest and then port it to, excuse me, I'm having a frog in my throat today. I ported it to WebAssembly and AssemblyScript. And the end result was a very familiar web dev experience. It's like you installed TS-Jest and TypesJest and wrote all your tests inside of TypeScript, except it's actually an AssemblyScript. And it was very successful. I also wanted to talk about what I meant by familiar. Most JavaScript developers who actually write their own tests will write in a syntax that looks exactly like this. They want to describe a group of tests and then create their tests and then perform some kind of expectation to see what happens with their code. Make sure that it works the way they want it to. So this compiles in Jest. This definitely compiles in Aspect today, and it's great. Of course, this came with its own roadblocks. And one of the things I noted was I can't actually run AssemblyScript modules through Jest because AssemblyScript has a slightly different standard library, and it has a slightly different low-level set of functions that you can use to access local memory, for instance. So it was hard to mock load and store functions directly. And of course, when you had to actually bootstrap the compiler into Jest, it ended up becoming a nightmare because you have to load the compiler and then compile your binary and then run the tests. And Jest didn't really like that very much. So it was time to actually start making something brand new. I ended up making a test framework that actually tested itself, which is great. So all of the expect functions are actually tested and bootstrapped by my command line today. And it actually uses Jest for a snapshot output to verify that things actually work the way they're supposed to. So let's actually build this testing framework from scratch, and I'll show you all the individual parts to see how it works. Aspect was much like the process of inventing the light bulb, where you need to fail at creating a light bulb numerous times before you can actually start at getting a light bulb to work. It's a very common phrase, turn of phrase. I'm probably not saying it right, but that's okay. So let's actually go through those things. So what do we need? WebAssembly is one of those languages that doesn't have error handling yet. And what I mean by that is that it has a very special instruction for causing the stack to unwind. And what it'll do is it'll halt execution of your code, unwind the stack, and then when the function hits the point where JavaScript call it, it will throw an error. And it's an unspecified error, so you can't really figure out exactly what happens. So what we had to do is we had to call out into JavaScript with a string that describes the error, unwind the stack, and then throw the error. And here's how we do it. Let's see. Aspect has a very special function called the trycall function. And this very special trycall function accepts a function pointer. This is actually a number. It's not a function reference. Like you can't just pass a function reference around in JavaScript pointing to WebAssembly. So what I had to do was I had to actually write a very special function called a call function, and then actually physically call that function pointer manually. And then if there is an error, we'll catch the exception and then pull the stack trace out of it and store it inside of the test context here. So this is actually JavaScript, and it's glue code. And what it does is it wraps around the WebAssembly module to try and call the function. Now, what does that call function look like? This is actually very, very simple. This is AssemblyScript code. It looks very familiar. It accepts a callback, and then you just call it. Very simple. Of course, you pass in a number to WebAssembly, and it treats it like a function reference. It's great. I would imagine that showing this function to junior developers, it would actually be very easy to explain what it means, simply because it's written in TypeScript. And this is taken directly from my source code, by the way. So now that we have a way of calling functions inside of AssemblyScript, let's actually build an expectation class. And this expectation class actually describes the nature of the test itself. It'll have some kind of actual value. And the way you pass in that actual value is by using the expect function here, and it returns a new expectation. So it'll perform a heap allocation and store the actual value on the heap. This is essentially the guts of the expect function that you've come to know and love as developers if you're a TypeScript dev and you use AssemblyScript, if you use TypeScript and Jest. And now that we actually have an expectation, we can actually perform a comparison. So for instance, the to be comparison actually determines if the values are equal. So here we have the to be assertion. We have some kind of expected value, and it's of type T. And also, additionally, a message that can possibly be sent up to the host if the assertion fails. And we'll go over the steps of how to actually determine if two values are equal here. The first thing that we do is we perform the double equals operator here on line 7. And we check to see if the expected value equals the actual value. Then we turn it into a number, an I32, which is an integer 32-bit number. And it'll either be 1 or 0 because it's a Boolean value. This is something special to AssemblyScript. But this actually becomes useful later, and I'll explain why. Then we report the actual and expected values. And here on line 10, we actually assert that the values are equal. Now, it's also possible to use the not property and then actually negate the assertion. And what we're going to do is we're going to determine whether the values are equal or if the assertion is negated. The caret operator in between them is the exclusive OR operator. And what that means is one value is 1 or the other value is 1. Otherwise, the assertion fails. And then it reports the message up to JavaScript and then displays an error on your screen if the expectation failed. And finally, if everything passed, we clean up the actual and expected values. And of course, there's these functions here, the most important functions. These are implemented by JavaScript. The describe, the test, and this particular throws function, I'll explain what that does in a second. Here, the describe function is just some function that JavaScript implements that allows you to describe a group of tests. And you pass it a callback and a description to describe what the group's name is. There's also the test function, which describes a test, for instance. And these are all global functions that you can access just like Jest has them. There's also this magical throws function here, which is a test that is designed to fail on purpose. That means that we expect this particular test to throw an error on purpose. And that's actually useful for testing things like assertions, and I happen to use it a bunch in my own personal testing of aspect. Oh, look, there's a question here. So does it support Jest's full mocking API and their auto mocking features? No. So there's a bunch of things that aren't implemented in AssemblyScript yet that would make stuff like that possible, like closure. Closure just doesn't happen to be supported yet. And there's a pull request open in process to actually get closure started. And I believe it would be possible to do the Jest full mocking API to actually detect to see if a callback function was actually called. However, at the moment, no. one of the most important parts of this framework is how the test algorithm works. And not a lot of people actually implement test collection algorithms, but they're pretty simple. The idea here is that this describe function here represents a test node, and it's a group of tests. And inside it are each individual test that shows up inside of the group. So for instance, a test, a second test, and a third test are actually children tests of some tests, which is the group here. The way that the test algorithm works is it calls each describe function and then says, okay, do I have any children? If so, then I loop over all of the children and actually call those callbacks. If any of those tests fail, the group also fails. And you, this isn't exactly obvious to you, but you can actually have tests inside of tests. And I've seen some Jest code bases that have this. Implementing this particular algorithm was a total nightmare. And I believe Bill was in the chat. He watched me have a whole breakdown about it. It was a lot of fun. So this is the part where I actually go out of my comfort zone and start doing a live demo. And hopefully the live demo gods won't blow up on me today. Let's start the workspace here. I actually have a Git pod here, and anyone following along can click on the link on the screen right now and actually get a live version of the repo that I'm currently using here. I just have to tell it to share my screen correctly. Let me see, there's the Opera tab.
All right, we're seeing your Git pod.
Perfect. I don't know if this is currently working here. Let's see. Huh. I can't see the files. The live demo gods have shamed me. Yeah, it doesn't seem to be doing the thing here. I'm actually going to close this out really quick and then try again. Everyone feel free to chat in the chat and see what's going on here, because I definitely don't know what's going on.
Any Git pod experts out there? Anyone who's run into this before?
Oh, create a fresh workspace. Here we go. Let's see if this does the thing.
All right.
Yeah, I just want to see the file structure because that's useful. I can work from the command line without it, but oh, perfect. Here we go. Let me share my screen now and everyone can see what I'm doing. Opera tab.
Oh, we see files, we see Git pod, we see command line.
All right, so we went off without a hitch, right? First things first, let's take a look at our freshly npm initted software here. We're going to actually change this package version because I just actually updated it. So here we have a few development dependencies. We're going to install AssemblyScript, and we're going to install Aspect, which is my testing software. You can see how easy it is to get started. Let's see, npx asinit dot. Ooh, I can spell, guys. All right, here. So this simple command will actually initialize your AssemblyScript project after you run npm install, because we don't have any node modules here. So let's start with that. And voila, we're already all set. There weren't that many packages to install, and I believe a lot of them, only 36. So that's actually pretty good. We're going to asinit, and what that will do is it will scaffold an AssemblyScript project for us. And here it lists a bunch of directories. It creates a tsconfig, an index file, a build folder, a whole bunch of other stuff. And all we're going to do is we're going to say yes. And voila, we actually have an AssemblyScript project up and running. The biggest thing that you'll want to see is how to actually bootstrap your AssemblyScript project here. So let's expand this out nice and here. Okay. So all we're going to do is we're going to read a file, which is the WebAssembly file that AssemblyScript will generate, and it will output our module for us, which is great. It also generated this tests folder, which I'm not entirely sure what it's used for, but if you want to test your software from JavaScript to see if everything works nicely, you can actually use this file. But for today, we're actually going to delete this folder because we're using Aspect to test our stuff. The next thing that I want to show you here is the assembly folder. Okay, let's save this. The assembly folder contains your AssemblyScript module. And as you can see here, this looks like a very simple add function. We're going to just return A plus B. Noted here, we have an I32 type, which is alias to number here in the IDE, but it's actually a 32-bit signed integer, and it gets treated that way. Most developers who use Rust will know this number type very, very well. So knowing that we have an add function here, let's actually generate a test to make sure that our add function works. And the way we do that is we have to bootstrap Aspect first. So what we're going to do is run the ASP command with the init flag, npx asp init. And Aspect doesn't ask you, it just generates a couple folders here. So it actually generates a tests folder, which should be familiar to Jest developers. And it generates a types file, and all this is a reference to the Aspect types. And finally, it'll generate a bunch of actual tests. So let's see if I can make this a little bigger so that people can see it. We're going to do everything from scratch today. We're going to add two numbers together. And the way we're going to do that is we're going to create a describe block, is what I call it. We're going to describe addition and pass it a callback. And then we're going to create a test. We're going to test the add function. The only thing that's left to do here is actually go check our add function here. It exists in index.ts. So let's actually add it. Import add from index. And voila, we have our add function. As you can see here, it actually aliases A to number and B to number, which is unfortunate. But we're also working on a plugin to get this nice and working well. And now we're actually going to perform an addition. We're going to expect add of 23 and 19 to be 42. And then we're going to log hello world to the console. The next thing we have to do is we actually have to run the Aspect testing framework by running it from the command line using npx asp. And as you can see down here, it sort of churns a little bit. But here, as you can see, it says that our test passed. And it also logged out hello world to the console, which is great. So we know that it's actually working. If we wanted to see a little bit more information, we can actually do the verbose command. And what that will do is it'll actually show you each individual test and where the stack trace was for the logged value, and that each individual test passed. So that's it's a useful feature for, at least for me anyway. As you can see, it ran here in like 2 seconds. It bootstrapped the compiler, compiled all the tests, ran the tests, and it was finished in less than 2 seconds, which is great. So yeah. I want to talk about some of the stuff that it generates for you as well. And here you can actually see a configuration file. Oh, I did not mean to do that. Oh boy. See if I can get this all back. Okay, can we see it still? Sorry about that.
Yep, you're good.
Okay, so here I want to actually go over some of the stuff that it generates. And here's the config. This is how we specify which tests need to be included. You pass it a glob. If you're familiar with the glob CLI, what this will do is it'll traverse all of the directories in the assembly and tests folder here and find spec.ts files. And all of those will become test modules. Let's see if we have any more questions. And here, we can actually specify if any additional files need to be included in our compilation. These come as include files by default. Any command line flags that you want to pass to the compiler when the compiler gets bootstrapped, you can pass them here. So here, we're actually going to pass this text file command here. And what this is going to do is it's going to output a text file that contains a text representation of the bytecode that it output. And here, this is actually where the module is instantiated. And you actually control how the module becomes a WebAssembly module right here. You have to call this create imports function. And then any of your imports, your WebAssembly imports, should go here. And the rest of it is not necessary to talk about for today. So here, we're going to make sure that a text file gets output, and we're going to actually see what our add function looks like. So npx asp, and the compiler runs, as you can see down here, and voila. Our test ran. It only cost us 100 milliseconds to output what's called a WAT file. And here, this is the text representation of the binary. As you can see here, this is a bunch of data segments that get written to linear memory to start. And these are all the imported functions that Aspect will use. There's not a lot here. Like, for instance, here's the clear actual function and the clear expected function. I'm just going to scroll through this rather quickly because I'm sure everyone is interested in the add function, which is what we're going to test here. So let's actually search for \add, add memory. Here we go. Here's our add function. I'm going to highlight it here. As you can see here, in binary, we can say that the add function has two parameters, and it results in an I32 value, which means that that's the return value. When we actually want to perform addition, we pretend that there's a stack of values, and this local get operation will push that value to the stack. Then this local get will push the second value to the stack. And finally, an add will be performed where the top two values on the top of the stack will be added, and only the added value will be left on top of the stack. Finally, the value left on top of the stack will be implicitly returned as an I32. We can also see our test function here by checking to see here. This is exactly what I wanted to see. Here are the magic numbers that we put into our test. You can actually see the 23 and the 19 here. And both of those values will be added because we called the add function. Those are the two parameters on top of the stack. Then we call the expect function, and this becomes the actual value left on top of the stack. Finally, we'll actually perform the comparison to 42, and then there's a couple magic numbers here. These are all pointers to linear memory, for instance, some of the strings. After that's all done, it'll perform the to be assertion, and then it'll log the string. See, the pointer to the string is actually here, the hello world string. And then finally, what will happen is it'll release the expectation itself. Remember, we had to create the expectation, and now the garbage collector has to come in and clean it up. This release function is very special, and what it allows us to do is it allows us to keep track of the reference count of a given reference in linear memory so that it can be garbage collected later. Here's the name of the anonymous functions too. As you can see, they get aliased anonymous, but there's an anonymous function inside an anonymous function, and surprisingly, this is exactly what that is. Right here, the add functions. I just thought it would be really neat to go over what the WAT file looks like and how Aspect actually will compile the tests and what it ends up looking like. So I believe this is the end of the demo. And I'm happy to ask any questions and use this to actually show you what stuff looks like if you might prefer. Let's go back here.
Awesome. So yeah, people have been asking some questions. You did some live already. Feel free to jump in there and ask any questions for Josh. I'll go through more comments that I saw earlier and just call them out. Something cool said, "Oh, this looks like PowerShell's testing framework tester," and they're not surprised. We answered the one about the full mocking API. Someone enjoyed your 42 joke.
Yes.
And also seeing the source code was super helpful. Something cool also said, JavaScript and WASM are second languages to me, but this talk shows me that I need to better learn my native languages testing frameworks.
Yes, testing is the most important thing you can do for your software. You should definitely understand what your software means and make sure that your users, when they consume your software, that you're responsible for what you put out as a developer. Like, you should definitely do that. And that was one of the things that I was very cognizant of when I made Aspect. So yeah, and there's a couple little things that I wanted to go over, and I wanted to share the lessons that I learned in actually making the software. And a few of them were actually really surprising to me. For instance, building new software for a new language is super hard, and you're not going to have any good time to do it. You're not going to have a good time doing it. Let's see. There'll be plenty of pitfalls that you'll have to navigate. And it's much like the Wild West, which is kind of why I chose this particular GIF. It wasn't, oh, dang. My presenting software has been very fun tonight. You're going to find bugs, memory leaks, and garbage collection errors all over the place, and that was definitely the case. Oh, code coverage metrics? I believe so. I don't know how to hook into code coverage just yet because WebAssembly is complicated, and anyone who wants to help me implement it would be greatly appreciated. But I definitely want to do it. It should be under the realm of testing software, yes. So back on topic, building software for a new language is hard, and you're gonna pull your hair out in frustration. Oftentimes, I found that the language changed underneath me. For instance, the garbage collection algorithm that was introduced made AssemblyScript great, but because my testing software had assumed that it was impossible for garbage to be collected, I had to do a lot of manual freeze, and I had to rewrite the entirety of my software from scratch when that happened. So prepare to fight your compiler, and sometimes you'll just have to wait for features to come down the pipeline. For instance, code coverage metrics. I would love to do that. It should be done. One of the things that I also found out that my personality isn't so good when it comes to actually completing projects. And sometimes my arrogance got in the way, and I know a lot of people who I work with will definitely know that I tend to do that sometimes. I tend to become arrogant. But the thing is, if you keep your head level and you remember how far down the curve you are in the Dunning-Kruger curve, I don't know if anyone knows what that is, but the less you know, the more you think you know sometimes. So just pretend like you don't know things, and that should help you out on your journey. Now, I want to talk about this particular problem that I found, was that optimizing modules tends to be slow, not optimized modules, because when you optimize your AssemblyScript module, it's going to be a lot faster because a lot of the opcodes were removed, for instance. And binary N, which is the underlying layer that compiles to WebAssembly, does a very, very good job of actually optimizing your opcodes. But the process of actually performing those optimizations is rather slow. So when you bootstrap a compiler and then you compile your software, it's going to be slow if you decide to make it do a ton more work. And as a result, I found it took like 4 or 5 seconds per module sometimes to optimize my software. And that was in the earlier days of AssemblyScript. But nowadays, it's not so bad. And I also want to say that if you're making software like testing hash functions, maybe it does become imperative for you to actually optimize your test modules. And what that will do is it will allow the hash functions to run faster so that your testing can happen faster. But every situation is different. And what you have to do is you have to actually tweak the parameters you send to the AssemblyScript compiler in order to make sure that you know which is fast and which is slow. Another thing, you really want to truly avoid function inlining, because that will cause the compiler to do a ton more work that's completely unnecessary for testing. Chemo Crossman says, it appears very verbose. Will that be refined? I don't know what you mean by verbose, so I'll continue the topic. You can definitely type out what you want to say. One other last thing that I wanted to say is that JavaScript is really, really fast too. Like, it has a lot of good uses, and as a dynamic host for tests, it does a very, very good job of optimizing how things should be done rather than what should be done, maybe. And don't count JS out, because it definitely has its purpose. AssemblyScript does a very good job of optimizing heavy loads. And sometimes your application isn't necessarily a heavy load. You shouldn't just write your whole application in AssemblyScript. You should definitely use it for what it is, and it's a tool. Let's see. I also advocate for not writing code you aren't proud of. A lot of the times I had trouble writing Aspect were because I decided I wanted to implement a feature that I didn't like and that I didn't think actually fell under the realm of testing software. So one of the things that I definitely want to do is make sure that my software does the features that I expect them to do. So for instance, Aspect, because it doesn't like to optimize modules, shouldn't be doing performance testing. That should be left up to a completely different tool. And I haven't actually created that yet, but I do want to create a performance metric tool later. So that's a good example. Just make sure that you have a game plan, you talk to your users, and then figure out underlying problems and fix those. Don't assume that your user has the answer to your problem by fixing this one little thing. Be confident in yourself and understand what you value as a human being first before you start making your changes. And this is the last one. I really want to make sure that I take help gracefully. This is one of the most important things to me right now, is because I don't do that. And I know developers who are really stubborn who definitely should learn how to take help gracefully. There's lots of smart people out there, and they want to help you. And they are definitely smarter than you are in a lot of different ways. Take their help and be the best developer that you can be. That's definitely what I'd like to say. So thank you all for watching my talk. I had a blast doing this, and I hope that everyone learned something. And I can field questions now. Please pop them in chat.
All right, we have a few more minutes for questions. I hadn't seen any ones that you didn't answer yet. And we'll have a break shortly until before our next speaker. But Josh, will you be around for a little bit?
Absolutely, I'll be around the whole night.
Great. So even if you don't get a chance to ask Josh now, feel free to pop it into the live chat.
Oh, repo. Here.
Yeah, feel free to post that.
I accept pull requests, by the way. Please, by all means, jump in and get dirty. We got all sorts of work that needs to be done.
All right, so there's the link to the repo. So I think Decode was understanding the other question from Chemo. The WAT file was verbose, and that's to this extent of generated output as opposed to what you as a developer have to write.
Oh yeah, so the WAT file output is meant to be verbose so that you can actually see all the bytecodes and the things that happen there. A lot of it is really verbose, and the reason why it's verbose is because the software isn't optimized, and it's meant to be that way. It's meant to be unoptimized. It becomes faster.
Awesome. Well, congrats. They're getting a lot of excellent talk and woohoos. And so, yeah, round of applause, virtual round of applause for Josh. That was awesome. We will be starting our next talk with Mitch in 9 minutes. So if you need to take a bio break or just stretch your legs, we'll be off video during that time. and we'll hop back in 9 minutes at the top of the hour.
I'm definitely gonna go take a break. I need to go stretch out. Thanks,
Yeah,
everyone.
well earned. All right, we'll see everyone back in a few minutes. Just popping in here. We have plenty of time. I realize it's kind of boring just to stare at an empty stream. I didn't plan anything to go in between the sessions. We usually have socializing. So what did they come up with? What can we talk about? I was hoping. Well, I was trying to figure out, like, hey, maybe we could do some live music, but of course, YouTube is very strict around copyrights. So I'm not going to show anything or play anything, but I want to just reference a talk from the WebAssembly Summit, which is really cool for everyone to check out, maybe even right now. I'm going to share my screen. Hopefully nothing won't be embarrassing. But there's an awesome talk by Peter about his WebAssembly synthesizer. Aaron, maybe I'll switch it over to you, which is super, super cool. It uses code to generate music, and he did a live demo, live coding, super fun. So just imagine that we had Peter here, and he was just rocking out with some synth tunes. Also, this is a great talk that you can go check out later from the WebAssembly Summit. Actually, his deck is also written in HTML, so he did everything from his deck, which was pretty pro. Let me stop sharing. So there's a conversation going on about who uses Emscripten. Any Emscripten users here? Yeah, I've messed around a little bit with Emscripten, trying to port a C++ command line tool. It was actually pretty easy. The moment you actually use it for a real project, I think, is when you learn the rough edges of transpiling and creating virtual file systems and virtual WebGL renderers. if you haven't looked at the source code for Unscripted, that is a monster project, and the team who work on it are pretty impressive. Oh yeah, there's actually a lot of good talks at WebAssembly Summit. It was the first sort of official WebAssembly, but not really. It was just by a bunch of volunteers, like Aaron was on the team, and yeah, let me WebAssembly. My talk was about WebAssembly IoT. Really, it's just been a lot of progression since my talk. The WasmSF team have been just cranking it away and improving the capabilities of their runtime. So you can go check out my full talk there. But it was about using WebAssembly outside the browser and actually in IoT, Internet of Things. And there's a really cool runtime called WasmSF. They recently added support for libuv, and so the same event loop that's used by Node.js and other projects. They've also self-hosted, so you can run WasmSF inside of WasmSF inside of WasmSF. I think they get to 5 levels, and that's when they can't go any deeper. Cool. Anybody? So yeah, anybody chiming in about their Unscripted experiences? Does anyone happen in the chat to know about similar testing frameworks for C code? C code. What's catch? C++ only? I don't remember. Yes, C++.
Okay, here, I'm back. I wanted to talk on that really quick, if that's okay.
Yeah, go for it.
So Jest tends to be, it tends to take advantage of the fact that objects have shape in JavaScript. So having a similar testing framework for C is probably not something you're going to find. However, you can write your own test functions and then just compile a binary and then run them, and that does a good job. I believe there are also really good C testing frameworks. Since it's a very old language, there must be something very good out there. However, I don't know of something similar. Live Telnet TS was written in C, and what I did was I compiled it using Mscripton, actually, and I have a set of tests that actually have, what are they? They're much like snapshot tests that were ported from the original C implementation. And all I did was I wrote JavaScript that does the actual comparison itself. It's a lot of fun. So that's fun. Yeah.
And I know of CMOC, CUnity, and CUnit are ones I've seen before. Just a list from one of those awesome type of lists. You find it more and more people are moving to C++ in the gaming world. It's largely C++. So you see a lot. There's a richer ecosystem around C++ testing frameworks. In the embedded in IoT world, where I play around sometimes, it's mostly C still. So you'll see, Unity is popular, not to be confused with the Unity game thing. This is WasmSF. I should send a link there. All right, I think we're at the top of the hour. Let people get back. Nice. So let's see. We have our second speaker, which will be a different talk than Josh's talk. Mitch also was introduced to us by Aaron. Mitch is over at Shopify, the e-commerce platform. And I didn't even know that Shopify was doing anything with WebAssembly, let alone AssemblyScript, until I met with Mitch. This talk was in part dedicated for another conference. Is that right?
Yeah, I had put this talk together for the WASM Summit, which was unfortunately not accepted. Aaron said I got very close, so next time maybe. But yeah, so this is a sort of modified version of that talk. I've taken out some content and replace it with a live demo, which should be better than slides. So
Awesome.
if it works.
Awesome. Well, we had luck with the last demo, so I'm crossing fingers and anything we can. Yeah. So warm welcome for Mitch, and I'll let you take it away.
Cool. Thanks. Okay, I'm just going to present my screen here, and I'm also going to kick off the local recording so that we can upload this after. So just bear with me. Okay, I think we're good. Everyone can see that?
Yep.
Awesome, cool. Okay, alrighty. Well, hey everyone, thanks for taking the time to listen. So my name's Mitch. Like Jonathan said, I work at Shopify. And today I'm gonna tell you a story of how we're making commerce extensible with WebAssembly. So that's me with shorter hair. I've got quarantine hair now. Graduated went to University of Waterloo, class of 2009. I've lived in Waterloo my whole life. It's a little town about an hour west of Toronto up in Canada. Big tech city. It was the birthplace of BlackBerry for those old enough to remember. And I've spent most of my career sort of working in startups. And since 2018, I've been a development manager at Shopify. So what is Shopify? It is founded in 2004, IPO'd in 2015. So it's been around for quite some time. It started as a software platform to help entrepreneurs start a business and sell online. And since then, it's evolved into a multi-channel software as a service commerce platform, powering over 1 million merchants globally today. So somebody says, anyways, if you've bought something online and it wasn't from Amazon, it was probably from a Shopify merchant, at least if you're in the United States or North America. And it's actually, I had here in my slide notes, like it was Canada's largest technology company by market cap, but actually as of, I think last week, it's now Canada's largest company, period, on the Toronto Stock Exchange by market cap. So it's grown like crazy, headquarters in Ottawa. Pretty cool company. So then we have Shopify Plus. And so at Shopify, we support a broad spectrum of merchants, from independent business owners selling trinkets out of a garage all the way to global businesses doing $100 million revenue. And so Shopify Plus is Shopify, but it's for high complexity or high revenue merchants. So those merchants at the really top end of the, the spectrum, operating globally, doing lots and lots of sales. And so I work on Plus, and as an engineer working on Plus, I get to work on the problems experienced by some of these largest merchants. And as you might imagine, some of these problems range from like volume-based scalability challenges. So a lot of these flash sellers generating just crazy load on the platform, all at a specific point in time when, Kanye drops a new pair of sneakers or something like that, and all the way to product complexity challenges. But today I'm going to talk to you about the challenge of how we make commerce extensible. But before I get into that, I'm going to dive a little bit into the tech stack of Shopify. And so Ruby on Rails. So Shopify, the core of Shopify is a 15-year-old Rails monolith. It's got to be one of the biggest Rails code bases in the world, if not the biggest. Not too sure if anyone's bigger, but it's grown up. Shopify's grown up with Rails since the very early days of it. And it's proven to be the right choice for the company in many ways. This image here is from a Shopify blog post about modular monoliths. And so on the y-axis, we have modularity, and on the x-axis, we have deployment units. And so assuming that a system has enough modularity to avoid the ball of mudness at the bottom, we have what amounts to a modular monolith versus microservice architecture. And Shopify sits kind of somewhere here-ish. And over time, it's trending more upwards as various teams refactor, reorganize, and figure out how 1,000 developers can continue to be productive working on a single Rails repo. We do have other services to take care of other jobs, but the core of the platform is really that Rails app that sits in the middle. It's our center of gravity. And so with so much diversity across our merchants' businesses, and with so many teams working on Shopify on an architecture like this, it's very critical to be disciplined and thoughtful when it comes to building product. We want to keep the out-of-the-box experience really simple for merchants and prevent our code from drifting downwards into the ball of mud. And so how do we do that? We have this product principle internally, which is we build what most merchants need most of the time. And so what this ensures that the things we build apply broadly to our diverse set of merchants while keeping the product and code base simple. But an outcome of this principle is that as the number of merchants grow, the number of things that apply to most of them most of the time, which is to say the intersection of the useful feature set, it actually gets smaller by definition. So over time, that core offering must get smaller. And so, but on the other hand, we need to solve more and more requirements. So what do we do? And so the way Shopify has solved this is with an app store. So we internally build the core, and we make the rest possible by having a thriving partner ecosystem in an app store, which you can see here as a screenshot from. And so through APIs and integration points, partners are able to build everything else that isn't what most merchants need most of the time. And you know, it's a huge business opportunity for them as well. We have merchants, or partners rather, making millions and millions of dollars selling apps on top of Shopify. So it's a great model. And with apps, merchants can satisfy their unique needs, partners can innovate, make money, and Shopify's core can remain simple. Okay, so this is a metaphor. So a metaphor we like to use internally to drive this point home is that of a computer operating system. So as most of you know, operating system, the kernel handles interactions with the hardware and exposes a set of syscall APIs that allow processes and apps in user space to do useful things on the computer. So I'm going to use this metaphor and apply that to Shopify. So in Shopify, we actually refer to our core Rails monolith as the commerce kernel. And this kernel exposes APIs to first and third-party apps, which you can see on the diagram. Those are just some logos from various apps. And then we have our commerce primitives, which are models like products, inventory, shipping, customers, those sorts of core commerce concepts. These are accessed via the kernel. So keep that in mind. I'm going to build on this metaphor a few slides later. I promise I will get to WebAssembly and AssemblyScript. I'm just setting the problem stage here. So here we might have an app, and it's interacting with Shopify in a few ways. So traditionally, these apps, they're hosted on their own infrastructure, provide their own UIs, and they'll use either GraphQL or REST APIs to talk to Shopify. Alternatively, Shopify might send a message to the app over some REST webhook when some commerce event fires, like say an order is placed and the app is registered to listen for that event. And these APIs and webhooks make Shopify extensible, and apps add value to merchants by exploiting that extensibility. So for many merchants, a few apps plus the core of Shopify is usually more than enough to run their business. But when you get to merchants at the plus level, their setup normally ends up looking something like this. And so on one hand, this is really good. It's the system working by design. Merchants can grow their business, and as they grow, they can add new apps to solve new problems. But on the other hand, there's a growing number of dependencies on these third-party apps can have costs. And so one of those is just an inconsistent product experience, with each app bringing distinct design patterns. There can be interaction effects between apps, and then there's scalability challenges. So a lot of these apps infrastructures just can't stand up to the load generated by large merchants that are doing flash selling. This is a very hard problem, and Shopify's spent a ton of money on this problem. A lot of these independent app vendors just can't do it. Furthermore, this type of architecture limits us to what I call coarse-grained customization. So having a really good REST API is useful, but what if a merchant wants to customize the deep internals of the system at a finer grain than what is exposed through, say, a REST API? So an example here that I'm going to build on throughout the talk is discounts. So Shopify provides out-of-the-box models for expressing some kind of a discount rule, and those models can be set up via an admin or via API. And so you can do things like buy one, get one, percentage off, and so on. But some merchants, especially the plus merchants, they have very complex promotions that could not possibly be expressed with these models. It would be crazy to try to build a UI to capture some of the promotions that these merchants run. And so, yeah, on the other hand, since most merchants don't need that type of complexity most of the time, it's our product principle to not overcomplicate our core to account for all of these possible promotions. So we need another way. We need to be more extensible. Okay, so metaphor step 2. I'm going to talk a little bit detour on this technology called eBPF. And so to be clear, our stack does not use this in any way, but it provides a pretty useful metaphor, so we use it. And so for those who don't know, the BPF comes from the Linux kernel, and it's a custom instruction set and a virtual machine for running those instructions securely inside the kernel. So a program is written in C and compiled to BPF bytecode, loaded into the kernel, and it runs in kernel space on some kernel event. And that program is actually provided by a user space application, but it's running in the kernel. So the initial use case for this was to allow user space processes to define their own logic for packet filtering. But since then, BPF has evolved to include many more program types across the Linux kernel. And so back to my simplified operating system diagram. Recall we have our user apps, our kernel, and our hardware. And so with BPF, we can have event hooks right inside the kernel that allow these user space programs, these user space BPF programs to run. And the instruction set actually is not even Turing complete. And so that's by design. Things like loops are disallowed. And that's so that each BPF program is guaranteed to finish quickly. And by having its own instruction set and VM, it ends up being secure. And so what does this allow for? This allows for safe customization of the deep internals of that kernel. So it's great for companies who need it because, you know, programming the Linux kernel can be really challenging, really risky. You don't want to maintain a fork. And this is actually gaining in popularity more recently with infrastructure teams at companies like Facebook and Netflix, both using this. So for things like load balancing, DDoS mitigation, observability, it's a super useful technology, and it's growing. So I think this was really cool. I'm going to use that as a metaphor to talk about what we're doing at Shopify. And so back to Shopify and our problem of making it extensible. So we asked ourselves, you know, how can this BPF type of architecture apply in our commerce kernel, our Rails app commerce kernel? What if these Shopify apps could run their own code securely and synchronously right inside of Shopify in a safe way? So could that help with performance and scalability of those apps? Could it help with the UX consistency problem I described? And could it ultimately allow partners to solve more complex problems for our merchants that they can't solve today? So if we could poke these extensibility holes in the monolith or the commerce kernel and allow for synchronous customization of Shopify's commerce processes, we thought that, yeah, we could definitely solve a lot of these problems. So this is a fake quote, but you know, someone maybe said, let's build a development platform for synchronous extensibility of a commerce operating system. This was kind of the mission we set out to solve. But of course, if we want to take untrusted third-party app code and run it synchronously on our most critical systems, you know, keep in mind these are real money transactions that are directly affecting the livelihood of more than 1 million merchants. So this is a very critical chunk of software. So that if we wanted to do this, it would need to be both fast and of course secure. And so we set out to look at technologies to solve this. You know, we looked at V8, Google Functions, Amazon Lambda, other solutions to sort of serverless technologies to run untrusted code based on containers or VMs. Many of these suffered from cold starts or just slow execution performance. And you know, a key requirement for us is because these customizations are running on commerce hot paths, so they are running right within the checkout process as somebody is buying something. Performance is absolutely critical. We can't wait for a cold start for a container to boot or anything like that. So I'm sure maybe you can see where this is going. So yeah, we decided to see if we could build this platform with WebAssembly and AssemblyScript at its core. And so we started with some prototyping, and we actually found in our early prototypes that WASM gave us the performance we needed. So it was super fast. It had compelling security properties, just didn't have cold starts at all. And it provided lots of interesting options for the dev experience, like potentially the ability to support multiple programming languages in the long term. And so I'm going to take the rest of this talk. I'm going to walk you through what we've done. I'm going to flip over to the live demo and sort of hopefully answer the question of how we can extend commerce with WebAssembly. So time to demo. This is in production, by the way, so it is very real. Terminal shows up. I'm assuming this is all good still.
Yep.
Cool. Okay. So here I have a terminal. Now I am acting as a Shopify app developer. So third party, not Shopify employee. I am building apps that I can sell on the App Store to add value to all the merchants on Shopify. So as a partner developer, I have access to this command line. It's called the Shopify App CLI. It's a fairly new piece of technology, but Shopify released this late last year to support app developers who are creating apps. And with this CLI, I'm able to create what we call a script project. And so our product is actually called scripts. And so you'll see that word thrown around in the various commands. And so I'm going to start by calling Shopify create script. I'm just going to call it WasmSF. this is prompting me to describe or to pick the API I want to use. So we have a few APIs available. For this one, I'm going to use a discount, and that's back to our what I described earlier, which is that some of these discount rules are just super complex. And so we'll see how I can define my own discount rule with code. Cool. Okay, so I've got my project bootstrapped. I'm going to open that in Visual Studio Code, and let's look at what we got. Right on. Okay, so we have source and test directories. Pretty simple project structure to start. And everything we're doing here is AssemblyScript and WebAssembly. And we're also making use of Aspect as well for the testing stack. So what do I get? So if I open up my script.ts file, I get some function signature here. And this is really the kind of the most important part to take in. So this function accepts a checkout, and it returns a set of discounts. So as a developer now, all I have to do to implement some meaningful discount logic is I have to map this checkout object, which I can look into that API. It captures all the details of the checkout as the buyer is going through and adding products to their cart. And I can map that to a discounts return value. I'm just going to nuke out these comments here. We also provide out of the box a default, I would say just example script that does something that they, rather than giving them an empty function, we give them some example code. So this example code, very basic. It iterates through the line items on the cart, and it applies a 10-cent discount to every line item. So this is what I get to start. I also get a test file. So this test file, again, provides some useful defaults. It tests the default function implementation that I got in my source directory. And so this is, again, based on Aspect. And we integrate that with the CLI. So as a partner, I can just do Shopify test. And so this wraps Aspect. And so out of the box right away, I have passing tests. And so let's go through making a tweak to this logic. So let's imagine I want to add a $100 discount to products that are on clearance. And I know that I've already gone ahead into my products admin and I've added a tag. So I can actually show you real quick what I mean by that. So here I'm flipping over to my store admin. So now I'm acting as a merchant. And so I have 6 products in here: high heels, jacket, jeans, runners, and t-shirt. I believe the t-shirt has a tag called clearance. And I believe also I've set up, I think the high heels maybe have clearance. Yeah, they have clearance tag. So what I want to do is I want to write some logic that applies a heavy, deep discount to anything tagged with clearance. And just to kind of reiterate why that's important, I'm going to go over to this tab where I can see this is Shopify's admin out of the box discount screen. And so this is where I can describe some of those simple discount cases I told you about. I can use a percentage discount, a fixed amount, a buy X, get Y. But one thing, for example, I can't actually apply a percentage discount by a tag here. So it lets me pick by collection or by product, but I can't actually do it by tag. So if I want to do that, and I can't do it through this UI, how can I do that? And so that's where our platform comes in, where now I can allow a partner to write some code to express that discount. So I'm going to go back to my VS Code here and make that work. So
hey, Mitch, you mind bumping up the font just a little bit?
Yeah, no problem. How's that? One more?
Yeah, one more. Perfect.
Okay, cool.
Thanks.
No problem. Okay, so I'm gonna just do a real quick change to this script so that I'm not in here for half an hour. So I'm just gonna extract this line item variable and call it item. And I'm just gonna do that. I'm gonna say if the item variant product, and there's a tags collection. So if, and that I believe is an array of strings. So if that contains the clearance value, then I want to apply a discount. Is it not contains? What is the right?
Includes.
Is it includes? Yes, it is.
Yeah.
There we go. And I'm gonna do $100. This is cents right now. And I'm gonna say WasmSF clearance discount. Give that message. I save that. And of course, if I Shopify test, I expect my test to fail. We get some nice aspect error messages here. And so no discounts were returned. I expected 2 discounts. So let's go edit that test. I'm gonna flip back over here. This here is my fake. We have a bunch of builder and factory classes to support the developer to build their own cart and checkout objects. And so here in my test, I have, I think, a red delicious apple and I guess another Florida apple, maybe. I don't know. I guess that's maybe, I don't know what that is. Anyways, so I'm gonna add a tag to this one here. And clearance. And so then I would expect now only to see 1 discount that is sorry, I think $100 is that. I gotta go fix that. There we go. And I think I said, I'm just gonna copy paste that string into my test file. And so now if I Shopify test, oops, I should see. Cool, so tests are passing. I'm happy with this code. I want to actually run this. So any merchant that's running my app, I want to ship this code to them. I'll show you real quick that this here, this is back to Shopify now as a merchant. There is an apps tab. And so as a merchant, I can see the apps I'm already running. So I have this Mitch March 4th app, and this is the app to which I'm programming as a developer here. So let's run Shopify deploy. And so this first runs a slow query that needs a bit of tuning to get the list of organizations. So this is it already knows who I am, and so it's fetching a list of organization objects that I'm a member of, so that I can select the one I want to deploy to. And so you'll see what that looks like when it comes back. Okay, so I'm using this organization, and this is the list of apps. So which app do you want to associate the script to? So there's my March 4th app. I'm gonna pick that one. And so then now this runs AssemblyScript, compiles the code, and does some other compiler hook stuff that we've done. And says I already have a script running on that extension point. So I forgot about that. So I got to force. This is just a check we have to make sure that the developer's not accidentally deploying something right over top of something else without knowing very clearly what they're doing. So force deploy that. And another step that I have to do, so now it says cool, the script is deployed. We have another lifecycle step, which is just called enable, and that can be done through UI, that the merchant goes in and clicks a button. I can also do it through the CLI. So by default, the deploy doesn't actually activate any code. It just hosts the source, the WebAssembly on Shopify. So I need to enable that separately, and apologies, we've got to wait for this fetching organizations query again. This should be the last time. So pick my business, pick my app. And so there we go. So we can see that that code is now turned on in this Mitch dev store. And that is the store that I've been showing here. And so now that code is running, what does that actually mean? So I'm gonna flip over now and act as a buyer on that store. So this is my storefront. I have not done any branding or fancy UI for my storefront. So this is like the stock storefront you get with Shopify. But I got my catalog here. So I'm gonna fill up a cart. So let's add a pair of running shoes to my cart. I want to add a pair of high heels to my cart. And let's add the t-shirt as well. Okay, so now we're going to go through the checkout so we can review the cart. And cool, so I want to check out. And if the demo gods are happy, we can actually see right here. So immediately in line, synchronously, I have the WasmSF clearance discount. I don't know why that's, oh, it's free because it's $60 and I did $100. So there we go. Whereas this high heels is regularly $250 and now $150. And because the runners weren't tagged with that clearance tag, of course, the discount is not there. And so this is fully integrated. If I were to go through the checkout, I would receive that discount as a buyer. And that essentially concludes the end-to-end demo. I have a few more slides to go through, but this hopefully shows the way in which we can use AssemblyScript and WebAssembly to run custom logic to implement very complex business rules that we wouldn't want to code into our core monolith to avoid making it too complex. So we allow partners to inject their own code, and they can do it in a really secure, high performance way with WebAssembly. So I think it's pretty cool. This discounts is just one use case of many we hope to build, but that's sort of it for the end-to-end demo. So maybe I'll zip through the rest of the slides, and if there's any questions on the demo or anything, we can get to that at the end. So cool. Okay, so just going to quickly go through sort of results and sort of challenges that we've seen so far with this. Okay, so it's fast. Latencies are measured in microseconds instead of millis. We've been super thrilled with the performance we're seeing on our stack. We're currently using Lucet as the WebAssembly runtime. I don't even know if I said that right. I don't know if it's Lucet or Lucet, but anyways, that's what we use. It's very fast. We have single workers able to do over 1,000 requests per second, and we're able to do hundreds of thousands of modules per worker. So the scale is just awesome. Tooling and language support. So this has been a challenge for us. And like I said before, or maybe I didn't say this, but the majority of Shopify's app developers they're used to programming in things like Ruby and JavaScript, on top of web frameworks. And so they're used to having these mature tools and large standard libraries and a lot of developer support systems. And with WebAssembly and AssemblyScript being fairly new, maybe folks know this, but there's not a lot of really great developer tooling built yet for AssemblyScript. So will we be able to give this audience AssemblyScript wrapped in our tooling, and can we sort of close the gaps to make that a pleasant experience and still allow these developers to get things done? And so for AssemblyScript specifically, things like having closures, good IDE support, having better libraries, these are things that would really help our developers and help us as we push towards launching this worldwide. And in the meantime, it's really about, can our team bridge those gaps and make it as easy as possible, maybe not perfect, but good enough. And so the other big challenge we have is good debuggability and observability. So things like stack traces, logging, tracing, and so on. If a script or a chunk of code fails, we want to be able to give these developers really good tooling around so that they can fix it. We don't want to give them, low-level, fault codes with no stack trace and just say, sorry, something's wrong. We want to give them something they're used to. And so this is a challenge for us. Not a lot of this comes easy out of the box, at least with the tools we're currently using. But it is exciting to be part of this kind of bleeding edge stack, and hopefully we can help really move the needle and make things better. So the last major challenge we're facing is in the API design. So this is specifically the APIs we're exposing to the app developers by way of the AssemblyScript classes. So if I look back at my code, right, this checkout object here, this discounts object, these have commerce APIs that we're exposing to these developers. And of course, I can click into this and explore what's available to me through that API. But this is a challenge because we're building all of this on top of a 15-year-old Rails monolith. And over time, the domain models of Shopify have evolved. Many are not perfect. There's a lot of technical debt like any large software system. And we don't want to expose any of that or leaky abstractions. We don't want to expose any of that to partners. And so we want to give them like a refined commerce API, but on the other hand, our team has to fit those call sites into, let's say, a fairly complex and very large code base. So that's a challenge. And that's especially complex in a world where we hope to expose many of these APIs available to partners. Okay, and so just to wrap up, just a few notes on what's next. So we're looking at WASI to see what we can do. So things like logging, observability, allowing these partners to write to standard out or to log some state associated with their script. There's some interesting use cases there. Things like permitting access to randomness or the system time so they can do different things. Today we just have pure functions, which creates some nice characteristics, but probably not sophisticated enough to solve all the use cases we're hoping to solve. And as we think about, can we expose a data store or caching or some other APIs to these programmers? There are some really interesting use cases that open up. We want to continue maturing developer tools, and so as we move towards releasing this to the Shopify partner ecosystem, we want this to feel like a tier 1 development platform. We don't want this to feel like some, you know, cobbled together set of hacks that they can use to maybe make something work. We want this to feel like they were building for a real tier 1 platform. And that's so that we can attract and retain the best developers who want to make the best apps for our merchants and add the most value. And so these things like debuggers, testing tools, deployment pipelines, libraries, these are all important to make that experience really great, really great. We need to add more APIs. So today, you probably caught the list. We just have a few of these APIs that you can use to program Shopify. In the future, we want to have tens or hundreds of these things so that the Shopify platform is deeply customizable with code in this way. And so that's just going to unlock a lot more value. And so if you put these things together, like the access to WASI interfaces, mature developer tooling, you know, comprehensive commerce APIs, these third-party developers can move beyond these small functions I've showed you towards building like really full-featured AssemblyScript applications that run entirely on Shopify's infrastructure and applications that'll guaranteed to be fast, secure, and scalable. And so that's going to unlock huge value for Shopify merchants all across the board. And I think this is all possible because of WebAssembly and AssemblyScript and the tools we're using, and Aspect, of course, in there as well, which is critical for our testing. So that is it. We're always hiring. Shameless plug. Connect with me. Happy to answer questions. Happy to go deeper on any of this stuff with the time we have left. So that is it for the talk.
Awesome. That was super cool. And we do have plenty of time for questions. There was a couple that popped up while you were going. So I'll read the back history, and anyone else feel free to jump in with more questions. I think this is mostly a joke, but have you all take a sip of the Elixir yet? I'm assuming the Elixir language framework.
I have not drank the Elixir yet, no.
And so then Oren asked, there's a back and forth around his questions. Does the developer upload the builds to your server, or is it built on your machine?
Yeah, so currently all the build happens locally on the machine. We ship AssemblyScript, ASC with our tooling. So that's all done locally, and we just accept the module and host that on our server.
Great. And a question for me then, is it executed fully server-side and part of the rendering pipeline of the page, or is it running in the browser?
It's executed fully server-side, yeah.
Cool.
Yeah.
Cool.
Yeah.
There's a suggestion from Deco to mine some Bitcoin while you're at it. I don't know if you looked at this extension of your business model, or maybe it's monetization for the app developers.
Yeah, maybe.
Mike is asking, what was behind the decision to build this instead of using a language agnostic solution, using something like MQ protocol or PubSub?
So, I mean, I don't know about, like, one of the big properties that's important here is that it's all synchronous. So something like a PubSub, I'm not so sure that whether or not that's synchronous or asynchronous. I suppose by default we're talking asynchronous, but even if we, waited for some remote server to answer a question, this is actually what Shopify already does. And so I alluded to that before, where there's these hot paths. So discounts may be an example of one, but a better example is actually in terms of shipping rates. So Shopify in many cases will call out via HTTP to shipping providers like, say, FedEx or UPS, and we will call their API and say, here's the state of the cart. Can you tell me what your shipping rates will be for this address and this set of products? So we call an API for that. That's just over HTTP. The problem with this is that it's just too slow. And in the case of very significant flash sales, Shopify routinely takes a lot of these third parties down with relying on remote communications to their servers. So what we're doing here by running the WebAssembly synchronously on our technology is that we take care of the scaling, and we can run it synchronously and guarantee that it's executing in sort of under 5 or 10 milliseconds. So very, very aggressive SLOs that we can only reach really with this WebAssembly stack.
Okay.
Sorry, question?
Oh no, I was gonna just. And I think you also answered it earlier in your talk of how application developers build it today. You mentioned sort of there's HTTP APIs and other integration hooks that would be more similar to a language agnostic way, because there's some discussion around language. And actually, the related question is, what are some thoughts or opinions on choosing AssemblyScript versus others? Is it accessibility for existing JavaScript developers or something else?
Yeah, I'd say the main decision criteria was approachability for the group of people that build apps today who are primarily JavaScript developers. You know, asking them to learn Rust or C just felt like something that was sort of a blocker. And you know, there are other properties of AssemblyScript that are nice: performance, module size. We sort of, the community is great, and there's a lot of momentum behind it. So these were some of the reasons behind our choice. But sort of back to like the language agnostic question, our intention is long term, and we're architecting this way that any language ultimately will be able to run these scripts so long as they compile to WebAssembly. And so we're starting with AssemblyScript because we want to have really good APIs. So those commerce APIs, it's very important that we write that source code, and it's not just like code gen or something like that, because that's actually, you know, the most critical part. So as we bring on new languages, you know, it's going to be a lot of work to do that, but the technology architecture will support it. And so in the long term, we hope to have more choices, and AssemblyScript is just the starting point for us. Yeah,
there's one of the other questions was, is there roadmap plans for other languages even in the far future, or is it a bit too soon since?
Yeah, there's definitely like plans. I would say, I mean, we haven't even released this quite yet to the world, so we still have a lot of work to do to release this. You know, Shopify runs this thing called Hack Days, which is many companies have a version of this anyways, but like every quarter there's 3 days where people can just hack on whatever they want. And in the last Hack Days, someone on our team actually got a Rust SDK built working on the same platform. And so we proved that at least Rust could work. And so that was really cool. We had another team that tried to get Kotlin working on the same platform and couldn't with the Kotlin native WASM stuff. So yeah, there is plans. I would say that like there's nothing on a formal roadmap, and I have no personal clue what the next language would be, whether it would be Rust or something else. TBD, we're still all in on AssemblyScript for the first version of this.
Cool. There's what was somewhat a general question about WASM and WASI. The original question was, does WASM WASI currently support monkey patching? And actually, Duncan and your team jumped in a little bit. Yeah, any thoughts?
What was the question exactly? Here, I think I can field that one. Let me see.
Yeah, please. So Rishi asked that, does WASM WASI currently support monkey patching?
Monkey patching. Oh, I don't know what monkey patching is, but I do know that WASI support is coming down the pipeline. We have to wait for AssemblyScript version 0.10 because there was a loader refactor. And once that's all done and everything is all set, we'll be able to actually allow you to use WASI inside of your tests. Actually, like write the standard out directly from WebAssembly, which is really cool. As for monkey patching, I'm gonna field that to either Decode or Mitch here.
I'll pass on that one.
Yeah, I think
I'm just the manager.
Yeah, Decode is actually in the chat. He's the creator of AssemblyScript. He's been pretty quiet. He sort of likes to keep to himself. So,
but he did suggest the Bitcoin mining business opportunity. So you can think about that.
I'm sure that doesn't violate any of Shopify's terms of service. So we'll do that right away.
Well, if anybody knows about monkey patching, feel free to jump in the chat.
Not sure what that means. I'd be happy to answer if I knew what it meant.
Cool. Other questions? For Mitch or for Josh?
Yeah, bring them on. It'll take a few seconds for them to hear it.
I'll do a last call.
Oh yeah, I should probably put on my camera. Okay. Decode suggests that it's possible to modify a module directly using binary N, and you can bootstrap that in Node.js and do all sorts of cool stuff with that.
Cool. Well, were you gonna say something, Josh?
Oh yeah. So as for like monkey patching or stuff like that, like if you want to modify a module directly, usually it's just better to handcraft your WebAssembly using AssemblyScript, because AssemblyScript actually gives you access to the low-level functions like direct loads and stores to linear memory. So it tends to be really, really useful to just stay in AssemblyScript. Yeah. Very, very useful, very, very powerful language.
And Rishi, saying you're coming from Python Line, if you want to look at what one project looks like, PyIodide, it's a port of the Iodide project, which is a scientific stack compiled to WebAssembly. I think Mozilla was the one who did most of the development here, but you can see what it's like to execute Python in WebAssembly. There are other projects, but that's the biggest one I can think of. Yeah, so Aaron follows up with, but if monkey patching you mean that you can define your own imports alongside the WASI imports, then yes, you can import your own custom host functions for your WASM module. So cool.
Yeah, that's what we mean by writing glue code. That's exactly what that is. Like, you should definitely learn how to do that.
And Christopher asks, what's the rationale for using Lucid? I think that's to you, Mitch.
Yeah, so there's a bit of history there. Originally, we started Shopify has sort of like a set of blessed technologies for building new services, and Golang is one of those languages. Rust is not. And so we started out writing this service in Golang and needed something easily accessible from there. And we found this WASM VM called Life, Perlin Life, I believe it's called. And that worked for a while, but it ended up not being fast enough, and they only had experimental support for sort of AOT compilation of the bytecode. From there, we found Lucet, which seemed to have the sort of properties we were looking for. We ended up rewriting it in Rust and using Lucet, some of the crates there. And with the AOT compilation, it met the performance characteristics we were looking for. Yeah, seemed to check all the other boxes. It was already supported and by a company that was running this in production, so there was the credibility of that. Server-side WebAssembly was a primary use case for it, and so that was compelling. So those are some of the criteria. Is it the right long-term choice? I think it's TBD. We've sort of architected in such a way that we're assuming any of these choices could be wrong, including both the VM and even the programming language. We're sort of assuming that it's such a new industry like WebAssembly that and we're looking to build a platform that's going to last decades. Shopify is all about building for a long term. We always say that we want to be a 100-year company, and so that means assuming we're going to be wrong. And so it's Lucet right now. It's working well. Those are some of the reasons. Yeah, may not be that way forever. It kind of depends how things go. But those are some of my thoughts.
Awesome. Is there data related to the cold start times that you're willing to share?
I mean, there's definitely data somewhere floating in our, archives. I'd have to go looking for it, and maybe happy to connect with you, Tim, afterwards, and we can see what that looks like. If I can find it, I'd probably be happy to share at least some level of detail there. I just can't access it right now just because it would take too much time.
Cool. Oren wants to know the name of the bird. I think that's your bird, Josh. You're on mute.
I'm on mute. Yikes. Okay, so those birds, they just happen to be very, very loud. They're Amy, Sunny, and Ringo, and we think that we saved those birds from Petco, who weren't treating them so well. So yeah, they tend to be a little bit loud.
Awesome. Any other questions? Going once, going twice. All right, well, I think we're gonna call it a success, our first live stream. So huge thank you to Josh and Mitch for presenting and for dealing with all the craziness of trying to do a live stream for the first time. So I'm gonna clap near the microphone, and anybody in the chat can clap for you too. So thank you.
Thanks for having me. I really appreciate it.
Yeah, this was fun. Thank you so much. This was good.
Yeah, great talks. So we'll end the live streams shortly. Afterward, we'll slice this up and make the final videos available. And the chat will be in perpetuity. The next one, maybe next month. This went well. And we'd hope to do the same thing, finding people who are not based out of the Bay Area to present. So if you're working on a cool project you want to talk about, you're watching this now live or in a future YouTube player near you, reach out to us on Twitter or WasmSF, or just send us a note on Meetup. And with that, thanks everyone for staying up late or waking up early, and be safe out there. Cheers.
Thanks.